Hi guys, for today's lesson we're going to be dealing with float times and the critical path. So first up, some words to remember. What do I mean by the float time? So the float time is the maximum amount of time that an activity can be in standby or delayed without delaying the project. So the idea is that certain activities, they don't have to be done straight away. There's a certain period of time which they can kind of not be started when they're allowed to be started, and that without affecting or delaying the project. And float time is found for an activity by doing the latest starting time, take away the earliest starting time. So these things are found when you do your forwards and backwards scanning. The critical path, it's an ordered list of activities that must be completed as soon as possible in order to complete the project as quickly as possible. So the critical path is pretty much like a set of activities that are like your highest priority. You need to be making sure that the activities along your critical path are done as quickly as possible so that the project is done as quickly as possible. i.e., it's an ordered list of activities with a float time of 0. There's literally no time to waste with these sorts of activities, so therefore the definition of float time would be 0 for these sorts of activities. For example, consider the simple network below. So we can see here that we've just kind of got a snippet of a network. We can see that activity A takes 5 hours, B takes 3 hours, and C takes 6 hours. To do activity B, you need to have completed A because A is coming before B. But you can start C without completing A. Like C can be done at the same time as A. So the critical path here, we would say is this path along the top here. The reason is because A and B together are going to take 8 hours. And during these 8 hours, you can be doing C at the same time as this path. So the idea is this is the priority, and C does have a float time. Now, the idea is, like, this diagram kind of shows you what the float time of C would be. So because C only takes 6 hours, which is 2 hours less than this situation, if you don't start this thing for 2 hours, so like if you look at this diagram here, we know that the first 5 hours have to be this activity A. We need to start this one ASAP. It's part of our critical path. And then straight after those 5 hours are done, you need to start B so you can get those done in the first 8 hours. But during these 8 hours are done while A and B are being completed, you have to also do C at some stage. Now you could start C at the same time as A, so that means that C would be done in the first 6 hours, and that means that in the 7th and 8th hour there would be like nothing would be happening here with whoever's doing C, so there'd be some float time here of 2 hours, so float and float and float. If we delayed C by 1 hour, we'd have a bit of float time at the start, then we'd get C done in the next 6 hours, and then there'd be another hour of float time at the end where nothing's really happening with whoever's completing C. And we can also delay C by 2 hours here instead and get C done in the last 6 hours. So all these three different options, it doesn't really matter what happens here. So we say that C has a float time of 2. It's pretty much going to be these 8 hours, take away these 6 hours to get the float time. Okay, so some example questions. So consider the following network for a project. Forwards and backwards scanning has been completed for you. So as we can see here, all the forwards and backwards scanning done. What is the float time for activity G? So if we look at our activity G here, the box at the start of G is going to be this one right here. So G has an earliest starting time of 6 and a later starting time of 8. The float time is going to be the difference between these two numbers. So it's going to be LST take away EST, 8 take away 6. It has a float time of 2 hours, activity G. And lastly, what is the critical path for this network? So the idea is you want to look at your activities and see what activities have a float time of 0, where the EST equals the LST. So at the finish, you should always have your EST equaling your LST. There's no float time when you're finishing. And we want to work backwards and see the critical path. So we're going to be here. going backwards to 1919, that has no float time. We have to do that. Like activity J is a priority. Next, going backwards, we can see that activity H is a priority because of its box 1111. Activity E is a priority because it's got the box 66, no float time, and activity B is a priority. It's got 00 as its EST and LST. So I've highlighted there the critical path. So what we've got here, we need to be able to show that we need to be able to show the critical path on the diagram. We also need to be able to list these activities. So we've got B, then E, then H, then J. That's our critical path. So we need to put commas between those activities to show our critical path. Hope this helps with the questions. Good luck.